Hello friends and welcome to your channel GATE Questions ECE. So the next question that appeared in this year of GATE exam of year 2022 is question number 57. This question belongs to analog electronics and is based on transfer characteristics of a circuit. So let's see what is the question. A circuit and the characteristics of the diode D in it are shown. So these are given the characteristics of diode. The ratio of the minimum to maximum small signal voltage gain curly V out by curly V in is dash. So you have to give the answer rounded off to two decimal places. So let's see how to solve this question. So this is the circuit that is given to us and this is the characteristic of diode that are given to us. To calculate curly V out by curly in, we will firstly have to plot transfer characteristics of this circuit. Transfer characteristics are nothing but the plot between V out and V in. To solve any question that are based on diode, we have to use open circuit and short circuit test. So to begin with, always assume that diode is open. So you can see in the characteristics of this diode that this diode is open, that is there is no current in this diode whenever the voltage across diode Vd is less than 0.7. So let's consider the case 1 when diode D1 is off. So the circuit diagram in this case will be, so this is V in positive, negative, this is V out positive, negative, and here our diode is open circuit. So in case of open circuit, no current will flow here, and these resistances are each of 2K. Since the resistances are in series, so the voltage across each of these resistance will be same. So we can say there will be V in by 3 voltage drop across each of these resistors. So you can observe here, in this case, V out will be V in by 3 plus V in by 3. So it will be 2 V in by 3. So in this case, V output will be equal to 2 V in by 3. And this relation will hold as long as voltage across diode, which is Vd, is less than 0.7. As the voltage across diode is same as V in by 3, as these are in parallel. So we can say as long as V in by 3 is less than 0.7 volt, this relation will hold. So you can calculate it that as long as V in is less than 0.7 times 3, that implies V in is less than 2.1 volt. So we can say as long as this V input is less than 2.1 volt, the V output will follow this equation. So we have obtained the relation between the V output and V in for this case when diode is off. So now next case we will consider that the diode is on. So you can observe from these characteristics that when the diode is on, any amount of current can flow through it, but the voltage across the diode will be 0.7 volt. It cannot be greater than 0.7 volt. So let's see case 2 when the diode is on. So in the case 2, diode D1 is on, and when it is on, the voltage across it, that is Vd, will be fixed and will be equal to 0.7 volt, or we can say diode is behaving like a battery of 0.7 volt. So let's see the circuit diagram in this case. So this is V out and this is V in, and each of these resistances are of 2K. And here our diode will behave like a battery with positive terminal on the left side, and this voltage will be 0.7 volt. So the VD in this case is 0.7 volt. So the voltage across diode VD is 0.7 volt. Also note that diode is on only when V input is greater than 2.1 volt. This was the relation that we calculated in previous case. In case 1, when Vin was less than 2.1, diode was off. So obviously when Vin is greater than 2.1 volt, diode is on. So now let's see what is the relation between V output and Vin. So let's assume this current is I. So you can apply KVL in this loop, and we will get that Vin is equal to 2 times I plus V out. So we have to eliminate this variable I to get the relation between V output and V input. So let's write this as equation number 1. To eliminate this I, we will have to apply KVL in this loop. So applying KVL in this loop, we will get V input is equal to 2 times I plus 0.7 plus 2 times I. So rearranging, you can get V input minus 0.7 is equal to 4I. So that will give us I in terms of V input. So that will be V in minus 0.7 divided by 4. So putting this value of I in this equation, we will get V input is equal to 2 times V in minus 0.7 divided by 4 plus V out. So that will give us V input will be equal to V in by 2 minus 0.7 by 2 plus V out. So rearranging this, we will get V output will be equal to V input minus V input by 2 plus 0.35. So that will be equal to V in by 2 plus 0.35. So that is the relation between V output and V input in this case, for which V input is greater than 2.1. So combining case 1 and case 2, let's now draw the graph between V output and V input. So for case 1, V output is equal to 2V input by 3 when V input is less than 2.1 volt, and V output is equal to V input by 2 plus 0.35 when V input is greater than 2.1 volt. So using these two equations, we can draw the graph. So this is our V out axis and this is our V in axis. So let's assume that this value is 2.1 volt. For V input which is less than 2.1 volt, we can see its slope is 2 by 3 and it is passing through region. So this is the V output versus V input characteristics for V in less than 2.1 volt, and this equation is V output is equal to 2 V in by 3. So for V input which is greater than 2.1 volt, the relation is this. Its slope is 1 by 2. So here slope is greater and here slope is smaller. So the slope here will be less. So the graph will look like, so this line has equation V output is equal to V in by 2 plus 0.35. So you can differentiate this and calculate that for V input less than 2.1 volt, curly V out by curly V in will be 2 by 3. Similarly, for V input greater than 2.1 volt, there is also volt, curly V out by curly V in. So differentiating this, you will get it is 1 by 2. So this value is smaller and this is larger value. So it is asked in question to find minimum to maximum ratio. So minimum to maximum ratio will be 1 by 2 divided by 2 by 3. So that will give us, in denominator we will get 4, in numerator it will be 3. So that will give us 0.75. So this is the answer to the question that was asked in this year of GATE exam of year 2022. So in the end, I will like to inform you that at present a series on random variable is going on in our channel. So all those interested students who are preparing for the GATE exam or any other exam, they can watch that series on random variables. In that series, I will be teaching random variable in very detail, and every day I will be posting 1 to 2 questions, and I will be explaining all the concepts of random variables through questions. So learning concepts through questions will not only save your time, but it will be very interesting for you to learn in that way. So I hope that you like this video, and if you like this video, then please do press that like button and subscribe to my channel for more such video solutions in future also. So in the end, thank you all for patiently watching this video till the end.